Swift and Tips podcast.
Hello, everyone. My name is Pete, and this is Swift and Tips podcast. Welcome to another episode. For this one, I thought in something different, in something that I could share from my own. I don't know if you know me, but I'm an engineering manager in a mobile device company, and there are a lot of interesting things related to the technologies and the process we have inside, right? But just telling you my experience won't be so much fun, I will say. So I thought would be great if I could bring one of the greatest engineers from my team to maybe share the experience, because definitely developing for uh, medical companies is a totally different experience. And for this episode, I brought one of my greatest teammates and also friends. He's called John Knott. John is a senior principal developer in the team, and he has a lot of experience. I don't know how that knowledge is coming from. So, John, welcome to the show. How are you?
I'm good. Thank you. Thanks for having me.
Yeah, yeah. I always have your picture of you like this guy knows everything. I don't know how much experience you got from everywhere, many projects. So, and that will be one of the conversations today. So, I really appreciate your time here, and thanks for being here with us.
Oh, I appreciate you inviting me. And just to set the bar straight, yeah, I certainly don't know everything, but I do my best to fake it.
No, you're doing great. No, just kidding. So, no, you definitely. Well, as I said at the intro, maybe you could introduce better than I did. But you work as a principal engineer
hmm
um, in the company we work together, right? So,
hmm
and I would like to explore many things related to the process, because you probably, I don't know how much time you've been working in medical devices. I don't know if this is the only one that you worked in the past before, but I'm curious. Before starting with all of that, um, you're a man with a lot of experience, man. So, where did you where do you start? And also another question is, how did you transition from other technologies to iOS?
Sure,
That's
sure.
something
Okay.
interesting.
Well, I mean, it depends on how far back you want to go. I mean, I guess we can go all the way back, right? So I've been, I think professional experience is about 33, 34 years. I've been writing code, at least for fun, at least since for about almost 45 years now. So I mean, it goes all the way back
Wow.
to when I was 10 years old, and it's the I'm in fifth grade, and we had this was like 1978. That's you can probably do the math and figure out how old I am. But yeah, so we had one. The for our fifth grade class had a single microcomputer. It was a TRS-80 Model One that was like the first in the district that they had brought in. Just to kind of see, okay, it's this new thing called a computer. We're not sure what to do with it, but we'll put it in the classroom and see what happens. And for me, what the thing that happened a year earlier than that was Star Wars came out, right? So as a 9-year-old
Oh,
boy,
yeah, yeah.
imagine, like so many of my generation, right? That it really kind of, it overtook my life, so to speak, right? It really blew my mind, right? It was just a great movie. And so I think that I was primed to be really interested in technology and sci-fi kind of from that experience. And so when I saw there was a computer in the class, I was immediately kind of gravitated to it. 'Cause, this is also a time when video games were starting to kind of come out. I think we had an Atari 2600 game system, and so I was just sort of generally interested. But the only way to play with this computer, and just to set the stage, this is an extremely primitive microcomputer, right? I mean, it had a cassette drive that you could use this to store programs in. But if you wanted to play with it, you basically had to write code for it. So I would take the manual home,
Wow.
and I would sit at which my teacher was gracious enough to allow me.
Gigant manual, I will say, right? at
Well,
that time?
it was relatively small, but the idea is it introduced the basic programming language
Mm,
and some
okay.
of the things you could do with that. And so I taught myself basic basically by using this we take the manual home. I actually would sit at the typewriter and type out code and then bring it to school. And then during recess, I would enter it in. And so it's of course extremely crude type of things that I was trying to experiment with animation just by clearing the screen and running things different locations. I would write these little so-called games where you'd have to like hit the space bar at the right moment in order to capture something happening. But
Wow.
that kind of kicked me off. I mean, honestly, I think I was just super fascinated with the idea that computers were something that you could program and you could change how it worked and you could write your own sort of experiences and games, and that just set the ball rolling, really. So as far as professional experience, then I mean, I went to UCSD where I studied cognitive science, and that mostly because I was interested in AI, which is funny. It's taken basically 40 years for it to
Yeah.
catch up with what I thought it was going to be, right? But we were,
Yeah.
the program there had an emphasis on neural networks and parallel distributed programming. But of course, it was very crude, and the technology at that time was far behind what we have today.
Yeah.
But it set the groundwork for all the innovations that we have today, and especially they're coming fast and furious with generative adversarial networks and Apple Intelligence, all the other things that I think we're just now all of us are kind of, I think, a little amazed like how quickly it's sort of stepped up and become really interesting. But okay, so my first paid programming gig was working on Spark Sun workstations. So writing simple graphical code that was used by a company called C Space Corporation, and
Mhm.
they did weather. They basically had a product that was weather satellite telemetry, and so they had various customers, including like McMurdo Station in Antarctica, had their systems installed. So they
Mhm.
would use that in order to download and see weather information. And so that kind of got my start. And then from there, I was always been a Mac user. I mean, my first personal computer I actually ever owned was an Apple II Plus, and I
Really? Wow.
did a lot of work on that back in the day, and taught
Wow.
myself a study language, um, and never did anything incredible with that, but still, it was always I was always really interested in that, and then learned Pascal, then had a simple the old beige toaster style Macs when I was in
Mhm.
college, and learned Pascal from that, and then I got a job at a company that was basically a contract company that had lots of different customers, and that was doing Mac OS development. And this is we're talking about System 6, System 7, long before Apple it released System 10 and basically rewrote their operating system to set up in Unix. But that's what kind of got me going there. And so I did that for several years, and then I transitioned over to do web applications. I worked at a company called MP3.com back in the
I
day. Yeah.
so sorry for interrupt you, but I have a question there. So you
Mhm. Okay,
you
sure.
you, you work as a developer, making apps. I don't know if the app concept was something at that time, but making programs. So what was the technology they used? I don't know, because
So back
Objective came later, right?
No, yeah, exactly. So back then, actually we were writing the apps were written in C++ primarily,
Okay.
and the Apple had a development framework that was called I think it was called Mac App, if I remember correctly. It's kind of been a long time, but it was
Okay.
mostly um, a command line sort of like batch, like you make file, run
Okay.
things, command line type environment. But um, what we worked with was a tool that was called MetroWorks Code Warrior, and that was the first integrated development environment I ever saw. So it was one where you actually had a screen and there was integrated debugger, and you could actually step to your code. It was and they had their own class library that you could use to sort of stand up certain elements of the application, like basic controller logic and UI and et cetera, et cetera. So it was, in my opinion, a big leap forward from trying to use Mac app to do sort of development. And so, yeah, so the kind of things that we were over there, we had a variety of different clients. I'm trying to remember some of the different products we worked on. I remember, like, for example, we had some of our customers, we had a product line that would drive animatronics. So you think about like I don't know if you've ever been to Chuck E. Cheese, where they have
Yeah,
like the animated band.
my kid love it.
Yeah. Yeah, so I think I can't recall whether it's exactly Chuck E. Cheese with a customer, but that was kind of thing that like we had some control software that would control that. You
Mhm.
could in case you script different sort of movements and then run these scripts and run the animatronics and
Wow.
we had various customers. Like that company was based out of Los Angeles. This is actually interesting. This company was also the first work from home company that I'd ever worked at. So my first job, I would I didn't have to go into the office because there wasn't one. It was completely distributed. We had a what basically a bulletin board service that we would log into and share code and share tasks
So you
and
work
collect.
at home
Yeah, so
at
I
that
would
time?
work at home. Yeah,
Wow.
exactly. So yeah,
My
so
idea.
kind of yeah, exactly. It's kind of groundbreaking, right? In a way, it's like kind of set the stage for how it
Wow.
works today. That was one of the big innovations. Like, yeah, we can have developers from all over the country. We don't need to really have to have a central office. We can hire people in Indiana and people on the East Coast, and you know, I was being paid by the hour, but that was fine. We had a way to work that out. And so anyway, so that was my introduction, I guess you could say, to the Apple development ecosystem, is doing
Mhm.
Macintosh applications. And then I transitioned from that to do, as I said, web apps. So I worked at mp3.com.
Mm.
I had a brief stint actually where I worked as a Mac support person, really kind of the lead of IT, oddly enough, at the San Diego Supercomputer Center, because I had a friend who worked over there, and I was kind of honestly, I think after 4 years in my early 20s of working from home, I started to feel like I needed human interaction a little more, and I kind of wanted to have an actual job where I went into the
Yeah.
office and people and went to lunch and that kind of thing. So I left Art and Logic, went and worked for the Supercomputer Center for about a year, and or maybe it was 2 years. Anyway, I transitioned quickly, realized I didn't really like being the IT guy so much because
Mhm.
I was more interested in developing. And so I had an opportunity from there to start working at a research group that was part of the Supercomputer Center. I was basically just kind of their code monkey who would do things like write shell scripts and work on
Mhm.
some of their code. That was like a computer security group. And then from there, I found I saw that mp3.com was asking for inviting applications, and I don't that was one of the first real big .com companies that I can think of, right? That it was basically domain name speculation. For I understand, it's like Michael Robertson. He heard about MP3 as a technology and realized he could register the mp3.com domain name, and this is grew from there. Oddly enough, right? I mean,
Yeah.
obviously, it made a big impact. But so that was interesting. That was working on Apache web servers and writing web apps that used actually used Perl as our main programming language. And so I was
Prolog?
there. Yeah. So mods. So the way Perl would work is there was actually Apache has this ability to you could create modules which can plug into it and actually directly change the compiled executable for how the web server operated. And so
Mm.
this mod Perl was a way for then you could write web apps in Perl and in effect, the whole HTTP command response mechanism and produce dynamic web pages. Now, of course, that's no one does that in Perl anymore. Just a million technologies have superseded that. Into the art of the
Okay.
time. Um, and so, yeah, so I did that for several years. MP3.com, you can Google that if you want to see the history of that company, because it had a big rise and a big fall. We made some choices that ended up getting the company sued for $750 million. And eventually the steam ran out of that company. But from there, I continued to work in web apps, working for a company called Royalty Share, which is basically a lot of refugees from MP3.com formed this other company. Because MP3.com was an online music company. And people, while we were working there, some of the folks realized that all these little record labels didn't really understand how to pay and process royalty payments, and it was a very complicated domain for them. And most of these people, they're music executives, they're not accountants, right? And
Mhm.
so we stood up a software as a service company to help them, basically, to kind of to deal with that ecosystem. And so I was there for several years. And that was a great experience. That was my one, I would say, real startup experience. I think I was employee number 10.
Oh
Had
wow.
a lot of options that ended up not making me rich at all. Actually, never. Yeah, that's I still work for a living. But it was a great experience from there. And now, I was technically the principal engineer at that company,
Mm.
because I was basically the lead developer there running that software. And then I th- had an opportunity to go work at a company called Voxox, and Voxox is a local voice over IP company here in San Diego. And so they actually hired me because of my Mac experience. They needed
Wow.
something. They needed a Mac developer because they had a VoIP desktop app that they were trying to. It had some issues, and they wanted me to come over and work there and to help them fix that. I had a friend of mine who I'd worked with before Telecom who was working there, so that's how I got that job.
Mhm.
But really, I think 2 weeks after I started, we pivoted. Right, we realized this desktop app's going nowhere. Let's have John work on the iOS app that we're trying to build. And so that was really how I got into iOS development. Was just it was the need of the company I was at the time wanted me to pivot, and so I got
What
to
time
work.
was there when you started on iOS?
That was, I'm thinking 2010, I think. I'm trying to remember my resume, but it was pretty early, right? So it
Mm,
was like
okay.
2010, 2011, I think.
Mhm.
I can double check if just resume up.
Yeah.
It's a long. It was early. It was early
Yeah.
in iOS. I mean,
Mhm.
the platform had been out for a few years, but not too many.
Yeah.
And so yeah, that's what kind of got the ball rolling there. And I've been doing iOS development ever since. So I remember the first time, I had C and Objective C experience. I remember the first time, sorry, C and C++, but I remember
Mhm.
the first time I saw Objective C code, and I had that one of those moments of like, what is this? I've never seen anything like it. All
That,
the square braces, and it's like it kind of blew my mind. But like anything else, you just sort of get to work and figure it out. So
that's cool because normally, I mean, people like me that transition
Mhm.
to Objective C, considering Objective C like, okay, is what it is, but I don't know, I don't like it. To Swift, it's like, wow, this is magical. I don't know. Did you feel that transition when you saw C++ batches
Ye-
into Objective C with oriented programming language or
it
something
was
like
almost.
magical?
It's interesting actually because like C++ of course is an object oriented language, and so doing
Mhm.
I was used to the object model and that kind of concept. It was mostly syntactically that the whole way you use selectors to send the call methods, and
Yeah.
that whole syntax. That was the first thing. That was very different actually, for
Mhm.
me. But although once you kind of get over the syntactic differences, it's in the same sort of paradigms still apply. Objective C is definitely it's an interesting language because it gives you certain like runtime abilities like swizzling and things you can do like that, which may or may
Yeah.
not be a good idea. But I agree with you though. I mean, once I feel like once Swift came along and I started working with that, it was like, okay, this is I've gotten used to Objective C, and I worked in many apps and in several companies working with it, but I'm definitely a fan of Swift. I just think it's a much tighter. I feel like it's much more expressive as far as how I can
Yeah.
really construct data structures and models and build constraints and all of that. I'm a fan. Let's put it that way. So.
Yeah, yeah, me too. So, and it's great from your perspective, for example. I mean, that you basically started with Apple II, making,
Mhm.
mm, I would call it app just to everyone understand, but I think the app concept came later with, iOS, etc. Uh,
Right.
but but it's great. I mean, you basically has been a Mac user, Mac developer for always.
For a long time. That's true. I've
Yeah,
kind of I've really seen
yeah,
it go through a lot of different transitions.
yeah.
Technologies come along, you know, um, and nobody writes code in Pascal anymore. That's for sure.
Yeah, I think by the way, my first language was Pascal, and just
Mhm.
because I was in high school, touching not even able to make my own program. It was something that a friend shared with me. Say, "Oh, look at that! I'm a hacker because I'm making some triangle calculations with this Pascal
Mhm.
code," and was like, "Wow." That was one of my inspirations to study computer science later. Mm. But yeah, it was
Yeah,
one of the
there's
resources.
something magical, isn't there, about being able to like to tell a device what to do?
Yeah.
and it doesn't. It's I think that's one of the common threads of most people who end up becoming developers is they find that whole
Hmm.
process kind of magical.
Yeah. Yeah. Sure.
Hmm.
And well, speaking more about the iOS, well, you have been basically since uh, iOS 2, 3 working on this platform, and you have seen what we got from with Swift UI on the latest technologies. Uh, from your perspective in all those years, how has been the transition to iOS in relation with the technologies, with the APIs and things, compared with what you worked before or so? Do you feel what has been your experience uh, with this technology?
Well, I mean, I think there's been one thing that's interesting about iOS is that I feel like there's definitely been it's amazing actually how many of these frameworks that we still use today that reach all the way back. Some things like File Manager and some of the other things that are still daily
Mhm.
occurrences. And so what I've noticed in iOS is like just like it sort of mirrors the industry as a whole, where different ideas about how you design APIs and how you design interfaces have evolved over time.
Mhm.
Like the original iOS frameworks were heavily used the delegate pattern, and that was something that was new to me when I came to iOS. That wasn't really a concept before Mac in like the Mac OS program I was doing. Like, that's something that I think that innovation that they developed over at Next, and they brought that over when they ported all the Next App APIs over
Yeah.
the iOS, and so that kind of and that of course if you're doing UI kit development, you're still dealing with delegates, and that's a fine pattern I think for inverting dependencies and pushing things down. And then we saw more and more interfaces that would take in Objective C they were called blocks, right? But basically closures. None of
Yeah.
this functions you could pass in, and so you see a lot of interfaces built on top of that. When I first started to like concurrency was handled using either NS thread directly or using NS operation queue, and so you had to
Yeah.
know a lot more about run loops and kind of how that mechanism works. And then Grand Central Dispatch came along, and that I think revolutionized how people really worked with threading and concurrency by having this higher level abstraction. The queue is on
Yeah.
top of, and we still use that pretty heavily, like in many ways today. Um, and so I mean, it's always so it's like you can really see. I feel like you can tell how long a framework has been in the foundation code just by kind of looking at its structure. Is it based on a delegate? Is it based on using a closure? Is it now based on using async await? You know,
Hmm.
the new way of doing things. So that's what, and so but I think it's interesting how the APIs have managed to still stay relevant. It's not like we had to like stop and rewrite everything in order to still write Mac apps. It's just they just continue moving along, and getting better. And so and Swift I think is a not really big leap forward with that, because you can have things like protocols and constraints and the type system is just so much more powerful than
Yeah.
Objective C. So I think it for me that helps constrain and reduce number of bugs that we create in theory, right, and help build code that should be safer by design. You know, um,
Hmm.
so
Yeah. and
yeah.
and and for example, we are now recording a couple of weeks after TC,
Hmm.
uh, and they announce a lot of AI tools and some kind of
Right.
evolution of what we used to have in the Apple ecosystem. Now, iOS, Mac, iPads, all of them technically will use AI or ChatGPT under the hood. So,
Mhm.
oh, I mean, what 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 is your perspective for that? So, do you think something
Well,
good?
it's clear to me that we're definitely on a cusp, or really in the middle of a revolution. I think on how like just everybody interacts with computers again. I think about what an impact the internet was when it first came out. I remember when I first saw my first web page, I was still in college, and back in the day, there was a single browser, and it had as a default homepage the list of all the new websites that came online that week that you could scroll through. And so I can't imagine what that would look like now, right? I mean, it would be impossible.
Yeah.
And so, but this just the ubiquity of that and how much that's transformed society. I mean, we've kind of witnessed that in our lives so far, and I think that that generative AI and these large language models is another of these like transformative technology that's coming along. And I'm not sure anybody really knows exactly where that's going to go, right? So how that's going to impact us? I mean, beyond just using technologies like ChatGPT or the Apple Intelligence integration that's going to be more deeply embedded in apps that people write. Even just improving the performance of Siri and making it easier to converse with that tool and having it
Yeah.
be more intelligent about understanding our intents. There's also, and where that will lead to, I mean, we'll have to see. But day to day as a programmer, I'm really curious about some of these technologies like Copilot or other things that allow it to write boilerplate code for us. What that will be like, like how is it going to affect our day to day lives as developers? I think kind of remains to be seen. It's and so I know that certainly at our and we'll probably get into this a little more, right? I mean, it's like it depends on your industry, just how quickly you'll be able to sort of jump in and let AI write code for you. Yeah, but I think me, even though part of me has this sort of old curmudgeonly kind of, well, I want to write my own software and I don't want a tool to write it for me. But if you think about it, like that's what software development always is, right? Is having higher and higher level of abstraction. Like, so like when I write an app, I don't have to go down and write assembly language code. I've got hundreds of layers of other systems that I'm leveraging to write code. So this is kind of just another, in my sense, it's very powerful, the new
Yeah.
level of abstraction I think that we'll use to hopefully spend less time in the quote boring stuff and more time, trying to
The
actually
business logic. Yeah.
innovative. Yeah,
Mhm.
exactly. So
Yeah, and from your perspective, that's even a better, interesting perspective because I mean, like you said, so kids maybe at your time they had to learn how to use command lines and learn to programming because that was
mhm,
the only way to interact with the computer, right?
right.
And maybe earlier it was even more challenging, but now it's like, I mean, my kids eventually when they are in college they will just talk with the computer saying, okay, I need to make an app so with this feature, so could you just code it for me? Yeah, sure. Boom, there you go, you have your
Yeah,
app.
exactly. And what will that be like? I mean, just from a career path and just in general, you know, uh, the role of a engineer or a software developer in understanding how computers work and what's going on under the hood. I mean, like that was one advantage I think of starting with something like an Apple II or a TOC Model One is that, like as you say, to play with the computer, you had to program it, right? And also, the amount of layers between me and the microprocessor were far fewer. It was much easier. It was really understand what's happening. I kind of had to understand what a processor was and what a register was and what the stack is and what the heap is and things like that. And um, although I'm sure that's still taught in computer science classes, I wonder what it'll be like in 10 years. Will it be whole careers where you're basically just writing, GPT prompts? I mean, I know like you can look at job listings that are out there today, and they're, that there's a big demand for people
We are
who
hiring prompt engineers.
yeah,
Yeah.
exactly. What does that mean exactly? We'll see. Yeah, it's interesting, right? Yeah.
Yeah, I had a conversation months ago with someone saying, I don't understand why we are like the end of the world because we are now typing in a box, in a text box, some words to say something to a program, and and then that program will execute or give us a response. In this case, ChatGPT, and it was like, uh, it's fun because that's the thing all the time. The only thing now is that instead of using C, C++, Swift, or anything, now you're using natural language to communicate with the computer. So, but it's essentially uh, similar things. So you get an input from something that you have written, and then you receive a response. But let's see later. Maybe I don't know. So feature. It's I don't know. It's something that we need to learn to adapt. The society in general. Um, I was reading news this morning, for example, that EU was blocking all the AI things from Apple. Uh,
Mhm.
so I don't know. I mean, I didn't read so much details, and that's a lot of politics, I think. But the thing is that yeah, we also need people need to learn how to react and work together with the AI, because yeah, we can. There are good tools for the good, but also to make things that others can, you know, be hurt by that or so. So yeah, it's a
Yeah,
transition. Yeah,
exactly. And that's why I mean that's my main take on it is I don't think anyone quite understands where it's going because there's so much happening all at once, right? It's
yeah,
almost like this sort of gold rush kind of mentality where even companies like I don't know exactly what it is, but I know we better get on it, right? It's like everyone's which I understand, right? You don't want to be left behind. I feel like companies, even like Apple, maybe were caught a little flat-footed when the first Chat GPT demo came out, and people were realizing, oh, wait a minute, this has moved a lot faster than I thought it was going to. I mean, when I was I'm sure everyone probably is familiar with the Turing test, right? That was where Alan Turing's
yeah,
thought experiment that someday maybe we'll get computers that you can be able to chat with and you will fool you into thinking you're talking to a human being, right?
yeah,
I think we're there, really. I mean, I didn't expect to see that in my lifetime, to be honest. And now I think the tools are written such a way that they try not to masquerade as a human being, but I don't think it'd be that challenging if you wanted to set up a system that you wouldn't know. And I'm sure things like customer support or other sort of services where right now you go through these super annoying call trees when you got to hit a button, you want to talk to a representative. I mean, I think all that kind of industry is going to be transformed by this. So you'll soon be talking to using natural language to entities that probably won't be people. And
yeah.
and so, yeah, it's going to be interesting. And so, what that's going to mean to us as developers, are we going to suddenly, will there still be room for junior engineers if executives think that they can just have they can just talk to a chat client and have it write their apps for them? I mean, we're not at that point yet, obviously, but we'll see. Kind of see where it goes, right? Yeah.
Yeah, I think there are a lot of things in the air, and one thing that you mentioned about the that we are becoming more and more fooled by by the AI.
Mhm.
I think now is the I think at some point we will have to go back in a way of not making them so smart that can fool us. So
Right.
there was
Yeah.
a concept like the valley of I don't know, but something when you
The
see
Unreal
something
Valley, that concept. Yeah.
exactly what so there is something super realistic, and it's like it give you some cringe. It's like oh, I feel really uncomfortable with this tool or this
Mhm.
particular game or so. So I think we are already at that point, and it's amazing to see. Okay, what's next?
Yeah,
What should we do?
and I mean, other people have made this point, who have been talking about this, but it is really interesting how I think people assume that computers and technology, their job is to help with the drudgery work that people don't want to do, right? I mean, if you think about like cartoons like the Jetsons, where it's like you've got robot maids cooking your dinner for you, and primarily everyone's basically has this sort of leisurely lifestyle because computers are handling all kind of the menial tasks. I don't think anyone really anticipated that the big breakthrough would be AI coming along and essentially automating creativity, right? And
Yeah,
kind of getting involved in these sort of tasks. And I think that's you got to wonder where that's going to lead. It's like I don't want to be dystopian or anything like that, right? But it's like
yeah,
it's kind of a curious thing. It's like if I wanted to choose something that I wanted the computer to do instead of me, I don't think doing art is the thing I would have chosen, in my mind.
yeah.
So yeah,
It's
but
totally backward. They started with
a
from
little
the
bit.
art.
It feels a little
Yeah,
bit backwards. So yeah, we'll see. Exactly. And I mean, honestly, I don't want to be out of a job because someone has written tools that can write code for us. But we'll see. I mean, the thing to remember too is that these models are they're basically reflections of what humans have already done. I mean, they're trained on examples that they've already created, and so it doesn't mean they can't. One of the things about the way a generative adversarial network works, the way this generative AI is that there's basically it's almost like an arms race where you have two networks that are competing. One is attempting to simulate something, and the other is attempting to learn how to tell it's a simulation.
Yeah.
And so I think that's the big breakthrough, I think, and why we've had this big advance, and exactly how that sort of paradigm can be applied to different things. I don't. We'll have to see, right? I mean, if you can train a network to just start from scratch and write applications based on a prompt. People are probably working on that right now, and we'll see how far they get. So,
Yeah.
yeah,
We have we have coming years really interesting. Yeah.
right, yeah, exactly. Yeah, that's
Yeah.
good. I mean, that's one reason I love this as a career is that it's constantly changing. That's the thing about being a software engineer that I find kind of appealing to me is, I mean, on the one hand, it's a creative outlet for me, but I'm someone who really likes solving problems. I think it's really fun when when you have bugs or even the problem of trying to build something, where you just have a vague description, and you're trying to snap an application.
Yeah.
That's fun for me. But then just also having to keep my brain plastic and learn new technologies and learn new languages and learn new coding paradigms and learning new architectural structures and et cetera, et cetera. It's always moving field. The only thing I can think of that might mirror that is, suppose, medicine and biology, which of course is like the more, like that's an explosion of new things every year because they're constantly discovering stuff. And for us, we're constantly inventing things, but it's like you can't. I mean, I suppose I'm sure there's still opportunities for people who know COBOL and Fortran and can maintain legacy systems
Hmm.
because, but I've always loved trying to be as close as I can to the bleeding edge of technology as much as possible, and so I think that's what keeps this job fresh for me, and why I love it so much, really.
Nice. Yeah,
Yeah.
me too. That's why I'm here. So
Yeah.
yeah, and speaking about your current job, like
Mhm.
we said at the beginning of the episode, we work together
Mhm.
in a medical device company, um, and well, your role there is a principal role,
Mhm.
principal engineer, right? Working from an iOS project. But before moving to that, I'm curious. Could you explain to people that maybe are not familiar? Maybe some people are familiar with the senior role, and most of them want to join or achieve that new role. But maybe principal is way beyond. So, what is exactly what the principal engineer role do?
Well, that's an excellent question, and I guess it depends
Yeah.
on the company, obviously, right? I mean, so there's, it's you can consider it, I guess, kind of a rank, right? That a notion that kind of reflects the amount of experience I have just in general.
Yeah.
But in some companies, if it's small, there's no need for a principal engineer because maybe your senior engineer or your staff engineer, if you even have that rank, is doing all this work, right? But the idea I think of principal engineer is that I'm helping drive technology at a sort of a platform level to understand like what we're going to do and how we're doing architecture and how we're building apps to not just work on the current project but set the stage for future work that we're going to do. I mean, to be fair, I'm still an engineer, right? So I still write code. It's not like I'm just in at least I try not to be just in meetings all day and thinking about and
Yeah.
living in UML diagrams or something, So push comes to shove, and there's bugs and there's issues, and then part of so that's kind of my role. I think people probably have an idea of what software architects do, right? And
Mhm.
or system architects, where they're looking at all the business needs at a company and all the different projects and platforms and technologies. Like at our company, we have a medical device that our application communicates with, and so the system architects are in charge of understanding kind of where all these different technologies are going and helping to set set the shape of the work that's going to be done, so that all these different business needs can be accounted for. As a principal architect, and really, frankly, I think any software developer should have a software architect mindset to understand the point of abstraction, and at the point of how you design systems that can change over time and adapt. So that's, I think, as a principal engineer, I kind of stride the boundary between architecture and implementation. I mean, I help understand architecture, but I also am, am there to make sure that people on the team are learning correctly, and that the ideas are being applied properly. And sometimes, from my point of view, a lot of that is just by example. I mean, as much as I
Mhm.
can, I try to that's one reason why I think it's critical that I continue to write code and be a developer, because I want to make sure I understand the challenges, like at the keyboard level, right? So that if people are running into bugs, or they're running into problems, or don't know how to do things, they tend to turn to me to help them solve these issues. So it's kind of, so I have lots of hats I wear. Where some of it is,
Mm.
they're kind of helping make sure I'm the liaison between business needs and architecture, as far as, okay, well, how are we going to actually implement the things that they want us to do?
Mhm.
Also, okay, well, how do we make sure that the product gets released on time? And if there's any serious
Yeah.
problems, I can maybe kind of parachute in and help. How do I also, part of the role of a principal engineer is I think, to help educate more, help through programs, or at least mechanisms to help educate the more junior developers, and create, and so I think that at our company we're kind of transitioning, because we're close to our primary product launch. It's coming soon. I can say that, I think. But so we're kind of transitioning from building the rocket and launching the rocket to now. Okay, well, now we want
To
to
the
build
moon.
more rockets, and now we want to build a space station. It's like we want to. Now it's not. It can't just be a small. Our team's getting larger, and the number of things we need to do are continuing to increase. And so part of what I do as a principal engineer is make sure we're setting up programs, and there's people who are, others can take on some of these responsibilities for doing a lot of the day-to-day design, or a
Mhm.
lot of day-to-day work. So it's not just, so that the whole program can scale.
Yeah.
Uh, so I know, and so that's kind of a fuzzy answer, because it's kind of a fuzzy role, right? I mean, it's like, I don't think, one thing about being an engineer is that there aren't necessarily clear boundaries between these different layers. It's more just sort of a matter of degree, right? I mean, as I
Yeah.
said before, I think even the most junior engineers should be thinking about, and to understand, and keep learning, like, the principles of solid software architecture, and design, and abstraction, and encapsulation, et cetera. They're not necessarily thinking about, okay, well, how do we going to transform all of our code to be more modular, and to be able to allow things to, but they should understand what those concepts are.
Yeah.
But it'd be nice if I never had to fix another bug again, but that's probably not the case. It is, right?
No, I don't think so. Yeah. So, and you said something really interesting. So you communicate like the architecture part and the
Mhm.
implementation part, but one of the challenges I have faced, and many too, is how can we prepare for uh, reading and creating those architectural concepts. So when
Mhm.
someone needs to implement a feature, most of the time we need to investigate, well, how are we going to build that, right? Jump into the code is the last part, once, well, thankfully should be the last part once we understand the problem, right? And but what would you recommend for those people that maybe are in a developer role or senior role and want to become an architect or principal engineers? I know, again, that depends of the company. Maybe
Mhm.
at Google, Meta, any other company means something different than for us. But what would you recommend to see? Okay, if you want to become good at system design and an architectural part, what would you recommend?
Well, I mean, part of that is going to be asking folks like myself questions. If you have any, you never have to hesitate if you have questions about, I don't understand why we wrote an interface this way, or why I may have pushed back on, so like one of the things I try to do when I'm like doing code reviews or looking at pull requests is if I make a change, I do try to not just say change this to that. I do try to explain why what I'm going to suggest is better at sort of a higher level. Um, but I mean, I say, you know, again, it's an interesting question actually, and so I think that the challenge here for junior developers, uh, because a system, especially if you come into an app that's already been built and has a lot of pieces, it can be kind of overwhelming, right? There's a lot of different moving
Mhm.
parts. So part of it maybe is picking a smaller part of the system and trying to really understand how it works, and then letting trying to understand how it interfaces with the larger system as a whole, which will then sort of lead you to continue to explore how different layers we've built and different modules we've created. It's hard to, I to me, it's like even like just reading the code or reading our documentation, which we have a voluminous amount of documentation because it's the nature of the industry that we're in.
Mhm.
Um, it's helpful to read that stuff, but there's nothing really more. I think I mostly learned through experimentation, and it's like getting in there and making changes and trying things is probably the best way to learn stuff. Now, there are some things that I could recommend you could read. Like I have to say, probably the one of the books I've read that's had one of the bigger impacts on the way I think about architecture is the Solid Architecture book by okay, I'm forgetting the name. I always call him Uncle Bob.
We can leave it in the description if it's in
Yeah,
Amazon.
yeah,
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 feel free to
exactly.
show it to me.
It's out
Yeah.
there, but I mean, he now. I mean, and it's not that his ideas are holy writ or dogma, but he does a really good job, I think, of explaining like one of the most important parts of software, why we write software at all, right? And that's
Yeah.
because software's primary purpose is to change. Honestly, it's not just
Yeah.
about accomplishing something today. It's about being able to react to new features, new business requirements, new platforms to run on, as well as fix a bug that you may have not have realized you created. And that's difficult, right? Because it's such a complicated concept. There's so many
Yeah.
different layers in a software system. So that's really the thing that I would always encourage developers to try to understand is the point of layers of abstraction, or the point of encapsulating things into separate classes and trying to minimize what each piece does, trying to minimize what parts of the system have to know about other parts of the system. The whole reason you do that, sure, it'd be much easier if we sat down and wrote the entire app as a single function, right? It's just main and it does it all, right? And I've seen code written that way, right? And
I did it in my first year of the college. That wasn't a good
yeah,
idea.
exactly. Yeah, exactly. And so
Yeah.
we all have, right? I mean, sometimes it's just like, it's like, I don't want to, I'd rather just pass exactly this thing rather than set up some sort of protocol or come up with some more abstract way of dealing with things. But the point of abstraction is that allows different parts of the system to vary independently and to change at different rates. And so really the whole goal is if I want to add a new feature, I don't want to have to rewrite the entire app, right? I don't want to have to touch everything everywhere. Like, you have a good design is if you can make a minimal change over here, or even better, just create a new thing and plug it in, and now you have additional functionality, you have additional things that your app can do. Then that's a good sign of a good architecture. And I've been at places where, and this is I think always true. It's one thing that whenever you start a project or write a program, it's never going to be perfect. It's hard to get perfect
Yeah.
architecture ever, really, because it's so much complexity. And
Yeah.
so you have to, part of the job is continuing to iterate over things and improve as you go. And sometimes business doesn't quite understand that. They would rather that you wrote it once and never touch it again, right? So that not basically, and maybe in their mind it's like, well, you're wasting time. And didn't you already write that? Why do you have to go back in and retouch that feature, or the dreaded
That,
refactor word, right? That people seem
that
to be so
that's
scared of. Yeah.
always a fight from products versus development, right? Like,
Yeah,
justifying each other. Why are you
exactly.
wasting time on
And
refactoring?
so part of our job, and I mean, that's another sort of thing I had as an advocate as a principal engineer, I'm kind of an advocate for software development as a whole, right? And so it's
Yeah.
like educating the business people that this is actually a necessary and natural part of software development is refining it continuously, right? Because everything, especially in a mobile environment, where a new version of the operating system comes out at least once a year, and there's always major changes all the time, right? It's a very fast platform to adapt to. So expecting you got it perfectly in the very first time is just not realistic, right? And so the goal, as you live in a software project, you realize the places that maybe you didn't realize that you want to separate these concerns out. That it makes these things are need to vary in different ways, or that you want to be able to reuse this component, and you buried it in this other feature. There's always that kind of work where you need to quote refactor things all the
Mhm.
time. And the sign of a good architecture is that it makes it easy, right? That the
Yeah.
refactoring you have to do is not like a catastrophic blow the whole thing up and start over kind of an endeavor, but more it's like, okay, you make a couple isolated changes here and boom, now we have more flexibility. And so that's that's kind of a thing that you learn through experience, I think, and being involved in a lot of different projects. Software development isn't really something you can learn just by reading books or watching podcasts or anything like that, right? Of course, it's part of the inputs, but like anything, like learning to play the violin, I can watch YouTube videos all day on violin, but I don't own a violin, and I can't. Then I'm never going to learn how to play it, right? So you have to. It's a craft as well as a science, and you need to do it. That's so the most software engineers that I think are really good at it are people who just love to code and maybe have their own side projects, or at least will continue thinking about things all the time. It's not just the sort of a job that they do, but almost more of an obsession, really. That it's something that they find fascinating, and would maybe would do it anyway, even if they weren't being paid for it. To a certain degree, anyway. Not that I'm
Yeah.
saying I like getting paid for it. Let's make you understand that. But and so that's really, I think having your own projects and being willing to even take the code you're working on in your company, and perform some experimentation, and be able to see what happens if I make this change here, what happens if I try to break this out, is you got to play with it, right? I think
Yeah.
that's the best way to really learn and get
that's
better.
that that's what I say to my team also,
Mhm.
that okay, one thing is your job, and your job needs to get things done, right? And you will do it with the frameworks or the tools that you have to use, right, for that particular project. But if you want to learn more, uh, you need to absolutely need to go outside project. Maybe you don't have enough time to build a super application, but exploring is also good, because with those explorations you maybe found something really interesting to you, and maybe you can create something great. And otherwise you can be stuck for doing the same job, the same particular project, which is not I'm not saying that it's wrong, but for some people it's like, okay, I'm getting burned out of the same thing over and over and over for years. It's like a good fresh air for getting insights of something new. It's
Absolutely. I mean, one thing that I'd like to say is that, if you look at my resume, I've worked at a lot of different places,
Yeah.
in a lot of different domains and a lot of different technologies. And I think all of that has made me in my opinion, a better developer, just because I've seen that there's multiple ways to solve similar problems, and there's different perspectives that different environments will bring to that, and even just the constraints and paradigms of different programming languages kind of help change the way you think about things. I remember, early on, when trying to wrap my head around what's the point of object-oriented programming in the first place. I mean, like we start off as the basic program or whatever. Even like going from what's a subroutine, like that's a strange idea. You're like, okay, I call a thing and then it comes back, and we're interesting, right? And then the idea of packaging data and methods that affect that data together kind of made sense, but it was really an understanding, though, the concept of inheritance, and how then you're sharing code and elaborating on implementations using this object-oriented inheritance type of structure. That was kind of a paradigm shift in my head, and as well as like the industry adopting it. And now we're moving into that's I wouldn't say that's obsolete. It's not, right? But there's things like functional reactive programming or protocol-based programming where, I mean, back in the day, it was very common to have these very tall vertical class diagrams, right? You'd have a base class, and then you'd have a whole lot of derived
Yeah.
behavior. And we rarely see that anymore because there are downsides to that, right? I mean, I can't tell you how many times I would in order to do something, I'd have to override a base class in order to have it not do what the base class was doing and replace something else, right? And
Uh-huh.
if you're doing that, that means, okay, we were probably, maybe that wasn't a good design in the beginning, right? And so like having flatter, like I think that the word that comes to mind now is modularity or composability, right? Like building applications or building structures by having smaller pieces that have well-defined behaviors and kind of composing an application from lots of little bits, as opposed to having a couple of like super powerful Uber classes that try to do everything and try to get those guys to communicate. That's kind of been a change, but um, I'm not quite sure. Okay, kind of like I may have lost the thread there. I was talking.
No, that's fine. That's fine, John. I think you have a lot of things to share. So
Mhm.
that's it's great to hear you, because I think you're a man with a lot of experience and a lot of advices for the
Yeah, but
organization.
ultimately, okay. Now you're reminding me what I was trying to get to, right? So the fact that I've had lots of different jobs, that's something I would encourage. I mean, maybe as a manager, you may not encourage this as much, right? But it's like you shouldn't assume that you want to be at the same company for 10 years or 12 years or 15 years, right? I think it's important to understand as a developer that it's your career, right?
Yeah.
And you need to manage it yourself. And so if you feel like you're at a place and there's no, maybe you would like to move up, but it's already clogged with there's not really a clear pathway to get there because there's already too many people at a sort of the senior level that you'd like to move into. I mean, sometimes it does require you to perhaps look for another place to work, right? And I think it's, at least from my point of view, that if I look at a resume and I see that you've have worked at a lot of different places, that's usually a positive to me, right? That means that you've been exposed to a lot of different ideas, and you have a broader perspective, right? I can tell you that I have other friends of mine who were at the same company for 15, 20 years, and then that company maybe was sold and their position was eliminated, and then they had a really hard time finding another job just because their experience was so niche. They were really good at doing with that one thing. And so that the challenge of being an engineer is you kind of need to be both an expert in minutia as well as have a broad
Exactly.
understanding of software development, right? You need to sort of be able to do both. It's impossible to be, at least for most people like myself, right? It's impossible to be an expert at everything.
Mhm.
Um, so you want to demonstrate that you can obtain expertise if I give you a problem and you're going to spend some time and you focus on it. And but I don't expect when I'm interviewing somebody, for example, that they already know everything there is to know about Swift UI or Combine or anything necessarily. I would say that when I'm evaluating a candidate, the thing that's most important to me is just their ability to solve problems.
Exactly.
So
Yeah.
that's what really what matters. It's not whether or not you know the answer, you've memorized a bunch of stuff. It's that I can see the gears turning when I ask you a question. And I can see, okay, well, I'm going to take this thing and I'm going to try to break it down into smaller pieces and isolate the stuff until I kind of have a better idea of really what the fundamental pieces of this problem I'm trying to solve. And then you can work your way back up again, right? I think that's an indispensable skill. But it's something you can get good at, right? It's not something,
Mhm.
it's not you're born with that. It's just a way of understanding that things that seem overwhelming when we first look at it, they are, everything's built of smaller bits, and those bits are also smaller bits, right? And you should be able to find a way to decompose a problem down, and then come up with a way to implement it or solve the problem or isolate the bug or whatever it is. It's all kind of this sort
Mhm.
of breakdown problem solving is something that you do, not just debugging, but also when you're building things at the same time. So the problem in that sense is, okay, how do I build this app that they want, or how do I
Yeah.
build this feature that they want? But it's ultimately
Yeah.
the same thought
Eh,
process.
Exactly, because I mean, learning Swift UI, everything else is like, okay, this is what we got now, but maybe in the future that will be obsolete. But the way you solve a problem, no matter where it's a problem, maybe you can take more or less time than others. But the thing is that be conscious about the way, okay, I'm challenging myself to solve this problem, and I have a perspective of how to solve it. That's really valuable. So yeah.
Yeah, exactly. And even ultimately, to me, um, having done this so long, I realize that every problem has a solution. Sometimes as you see a bug and it's like I have no idea what's going on. It's like impossible to understand what's happening here, right?
That's not a
And
word.
that's never true. Yeah, I mean,
Yeah.
it might be really hard, and there might be all sorts of weird layers between you wherever the issue is. But computers are machines, and they are ultimately deterministic, and they're doing something because you told it to do it. You may not realize you told it to do that, because so many pieces involved. But
It's not their fault.
yeah, exactly. So I mean, it's like being tenacious is also something that I really appreciate in people. They just you may not be able to get the answer instantly, but if you just keep working the problem, you'll find a solution. It's always something going on.
Yeah.
Yeah.
Yeah, definitely. And well, John, we are reaching to the end of the episode, but I have an important
Okay.
question for you, and maybe there are some sub questions inside that. Um,
Mm-hmm.
you, like we said, we worked in a medical device company, and you know when you work as an iOS developer, you maybe have some experience about okay making an app and then launching them, right? But how that is in a medical project,
Mm.
because when you I mean it depends of what kind of medical project is, but in our case it's something about delivering insulin to patients, right, to people. So could you tell us a little bit, I mean, in your
Sure.
perspective,
Yeah.
how
I could
different is
probably talk
from
another hour about that if you wanted to.
yeah.
But yeah, honestly, so this is to be clear, this is the first medical device company I've worked for, and
Mhm.
I've worked for a variety of different companies, and you can find me on LinkedIn if you want to look at my experience. But the biggest difference to me is that the just that I say that the level of quality that we require, and the level of regulation we're under, but the regulation ties back to quality, right? It's like
Yeah.
what we're trying to do here is so important, and the margin for failure is so small. There's this particular mantra you hear a lot in Silicon Valley and Silicon Valley firms, which is fail quickly, right?
Yeah.
That's kind of the idea where okay, just try it and then see what happens, and then you iterate and you try some different things, and don't be afraid to fail. And I mean that's a great mindset in general, but it's a little different in a medical lab. Like like we can't. I've worked on applications where we release a new version every week, right? It's a very large apps, and so you're constantly iterating. And if you have a bug, okay, well then that whatever, maybe that person's not going to get their ice cream sandwich that week or whatever. There's like it's annoying, and you know what? Like everybody wants their code to be awesome and bug free and work
Yeah.
perfectly. I mean, it's not that people are slopping on purpose, but the consequences are different when it's something like a medical app, where if you have a bug, then someone's child dies in their sleep, right? And that's a much, much, much heavier thing to think about. Um, so that's why this the biggest challenge I see for as a medical app in a mobile device platform is that I think I mentioned earlier, right? The iOS and Android, these mobile platforms, they evolve rapidly, and
Mhm.
there's on a at least a yearly basis. And so, but medical devices, they by their very nature are conservative and need to be extremely thoroughly tested, and you need to be very careful when you're going to make a change to something, that you don't introduce regressions, and which then requires additional testing, and really the amount of testing and documentation load. And it's all because it's so important. It's because if you make a mistake, if you release something that has a fundamental flaw, not even just from a point of view of it's expensive for the company to ensure a
Yeah.
recall, it can be damaging to your brand and all of that. I mean, that's it's important, but also just you got to remember there's human beings out there who could be seriously harmed by the mistakes you make if you make mistakes. Um, so there's some tension there, right? I mean, it's like how do you continue doing the work of software development, which is iterating on things and making things better, in a way that doesn't introduce more risk. But you can't just freeze your code and never change it, because eventually the platform's going to leave you behind and your app's not going to run anymore, right?
Yeah.
And you're not fulfilling your mission either, right? I mean, our goal is to produce software that people use to make their lives better. So that to me is really the interesting thing about this job, is trying to balance these two. You need to be able to iterate and try to move quickly but also, you have basically zero tolerance for failure. Um, and ultimately, I guess in my head, that kind of comes back to architecture, right? I mean, like the
Mhm.
key there is to, especially when you first start out, is to try to make as much as modular a design as possible, so that when you do need to update parts of the system, or you need to fix a bug, or you just need to adapt to new features that are coming in the platform, that your system's designed to change so that you can
Yeah.
invest those changes quickly, and not require like the entire thing to have to be retested from start to finish, or the chances of introducing new questions are low. But yeah, so that is I think the biggest change, because I've worked at places where it's like, okay, whatever, I know there's a little bug, but we'll fix it. Just keep shipping, just keep
Yeah.
shipping, and we'll fix it. And so
I,
you can't really do that here. Yeah,
I've been working in companies. I won't say the names because I don't want to blame anyone, but
right,
big companies where they don't even test at all. And
sure,
I didn't even read or write any unit tests, and it was like, wow, that's crazy. But here, you tell me. I mean, there's no code review without any tests, and testing is really important, like you said. And maybe
hmm
not only medical, also, for example, core industries. It's in a way of, okay, I mean, if the brake is not working as expected, terrible things will happen. So they
right,
need
exactly.
to absolutely review every edge case. If they, I don't know, if they throw the phone from the window, what will happen? Are you going to lose connectivity? Are you going to restart the
hmm
app? What will happen if you got a crash? I mean, another company has like, oh, okay, a crash, meh. But
Yeah,
here, okay,
right, right.
it's people life in danger or so. So there are a lot of
Yeah,
things
I've
to.
also worked at companies where we didn't, where the software developers were responsible for doing all the testing. We didn't really have a QA department at all.
Ooh.
Um, and so again, that's that always struck me as a strange choice, because I think there's kind of a different in mindset between a developer and a tester. I mean, some developers make great testers and vice versa. It's not that they're like completely different, but they come at the product from a different point of view. And I think some people are just extremely good at finding bugs, and that's a talent. It's a talent that should be celebrated, and they deserve to have a career path. And those people, I love my testers who are really thorough and really great, and the fact that they can do things that I would never think of, is such a huge benefit, especially for something like this, right? And I think there's a little bit of a subconscious thing when if you're testing something you wrote yourself, you may I don't know if it's subconscious or what, you may decide, don't do that, right? It never occurred to you that, like, that, okay, I'm not gonna force quit the app in the middle of this process, or I'm not gonna try to, cut and paste a bunch of poop emojis in the password field, or whatever it is, right?
Yeah.
Just because it's like, some of your brain says, okay, that's a terrible idea, so no one's going to do that. Where the tester's like, oh, well, I can do anything I want. I'm going to try this thing you wouldn't have thought of, or would sort of subconsciously avoid, and find issues that way. So yeah, but unit testing is interesting too. I mean, I remember in a way, it's kind of a new idea. Well, I mean, it's been around for a good decade or so, but I worked at plenty of code bases that have very low test coverage. I don't think that's particularly uncommon, actually, right? I mean, a lot of things,
Mhm.
legacy code bases maybe have, where they have unit tests at all, it maybe not be very thorough testing. And part of that, again, goes back to architecture. There's a certain, when you're writing code to be testable, you may make different choices than if you're writing code that has a lot of global dependencies and makes it really difficult
Exactly.
to isolate things. In my mind, though, I think that good architecture and testability kind of go hand in hand, right? I mean, if you have good layers of abstraction, if you have good isolation of concerns, then usually that means that you have clean APIs and clean interface boundaries that you can test, and your dependencies are all well understood, and therefore you can write unit tests of high degree of coverage. And a lot of the choices that we made in our project were driven by that concept that we set ourselves a high bar. We wanted to have a high degree of unit test coverage, because
Mhm.
for both reasons, both because it's a serious product and we want to make sure that it is as bug free as possible, but also because I wanted that synergistic effect of having good architecture being essentially forced on us, because if you find yourself written in a way that you don't know how to unit test it, you probably don't have a good design, and you might need to break some things apart or rearrange a few things so that you can test it. um, so yeah, so that's definitely my take on unit testing. In a way it's almost more important. The architectural side is almost more important than the actual test coverage, although the test coverage of course is critical.
Yeah. So, and like you said, so architecture, testing, so everything, all of that is important. But in the medical devices, the company is even more important. So,
Right.
yeah, carefully, every single piece matters. So,
It's kind
uh,
of like I imagine this must be what it's like to a certain degree working for like NASA or JPL or things like that, right? Where it's like you spend, first of all, you spend $3 billion on a space probe, right? You better not fail, right? And
exactly.
your chances to fix it, I mean, you have one shot at your orbital insertion, around your planet you're trying to orbit. And if you got you drop a decimal point or something doesn't work and you miss, then that's all decades of people's work is gone. Now, no one dies when that happens, but still, it's
Look at what happened.
yeah.
Yeah, look at what happened with the SpaceX when
Hmm.
they wanted to launch a rocket, and they had an accident. They blow up a satellite from that's supposed to be a collaboration between Elon Musk and
Right.
Facebook or Meta.
It,
Yeah,
it,
that
yeah.
was a big issue.
It
And maybe
is interesting though. You mentioned SpaceX just because they brought this more of a Silicon Valley kind of rapid iteration approach to rocket design, which was very radical. It's like that is one thing. Then that's one thing. It's important to use that as a model and think about like what we do and continue to reevaluate like the decisions we make. Because like when someone like Boeing or other traditional um, vendors go through a project to write a rocket, they try as hard as possible to get it right perfectly from the very beginning so that they don't waste any money and their rockets don't blow up. Whereas when SpaceX was working on their boosters, and especially, they were okay with them blowing up. They would try to, in other words, like they want to blow up when they're actually launching people's payloads, of course, right? But the whole point is they were willing to iterate and tolerate a higher level of failure from the very beginning to learn things as quickly as they can, to try
Mhm.
stuff out. Um, so it mean, but there's a point as we're okay. That's great up until the point now we have people on the rocket, or we're sending actual, billions of dollars worth of payloads into orbit. And then at that point, hopefully you've worked out all the bugs and things won't blow up, right? I mean, they're having this issue that they're having right now with the Boeing space capsule. And the helium leaks and all of that. I mean, I definitely feel for the engineers but it's hard. I mean, obviously rockets are hard, and it's not like
Yeah,
these. And it's easy to say, oh, we just tried a few times and let it blow up. But it's like, if it's every single version is extremely expensive, um, it's hard. So, and that's the same thing with us, right? We really can't afford to just iterate and have a certain percentage of our people use our product, be harmed, and then we'll figure it out as we go. Like, we don't have that luxury. So, but we can't take 15 years to release a product because at that point someone else will have already lapped
e-
us.
exactly.
They'll cure insulin. Hopefully, think maybe they'll have cure diabetes, which would be great. That would make nothing make me happier actually than having that us be obsolete because that happened. But um,
Yeah,
yeah,
fear can stop the innovation, right? But we need to
right.
be have a full process because it's strict. Yeah, it's what it is. It's the nature of the business. So
Right. Exactly.
yeah. Hmm.
Absolutely.
Yeah. I have one last question before ending
Mhm.
regarding the technology. So, what I know the answer, but I would like to you to tell me your opinion. What is the technology that you use? I mean, for example, for making iOS applications, are you using UIKit or Swift
Mm.
UI, or what is the main architecture you use? I don't know if you're using anything out there like DCA or uh, reactive, etc.
Yeah. So when we had the advantage when we started this project about 4 years ago of having a greenfield that started from scratch, right, which is pretty unusual. And so
Mhm.
the team at that point, Swift UI was basically kind of the new thing that everyone was excited about. Reactive programming in general was something that people were interested in, and Apple had just, I think, announced Combine at that point. It started instead of using like a third-party RX Swift implementation. So those were the kind of the technologies that people were really excited for. So that the idea that we wanted to use Swift UI, I think, was one of the things that drove some of the decisions we made. We wanted to kind of, and part of that was the developers want to keep their skills relevant. Having an opportunity to work in the latest technology, was definitely attractive. But of course, the downside is it was new, so nobody had any experience with it. So we had to kind of all learn together. So our app, it uses Swift UI as it, essentially the presentation layer. But then driving that, we use the composable architecture, and that was a choice that was made pretty early on, and it touches on all the things we've talked about before, right? I mean, one of the things that's really attractive to me when I was evaluating different technologies where we were going to build or use more of an MVVM kind of view model type of architecture, or use some, I guess that the acronym now is MVI that describes what
Mhm.
TCA does, where you have a single direction of change, and you have well-constrained ways in which your state changes. I mean, one of the big advantages to that was that there was such a clean separation between your models that represent your UI state and then the view, which is observing that. But because there's not these two directional bindings between your view and your view
Mhm.
model, it made it much easier to have a really, really high level of unit test coverage. I mean, that is one of the big advantages in my mind of the TCA and the reducer-based um, architecture, is that you could have, in theory, virtually 100% test coverage at that level, right? You really can control not only how actions coming into the reducer change your state, but then the behavior of your dependencies, which are as side effects, and
Mhm.
that to me, I felt like that was going to be critical for us to feel like we had confidence that the code we were writing worked the way we thought it was supposed to work. And it also it helps, like anything else, having that high degree of separation between views and then view models makes things more reusable. I think like, again, and this is something we'll continue to iterate on as we go forward, and try to make more and more reusable, like UI components, et cetera, for different apps. But I really do feel like the app we've built has a better architecture than virtually any other app I've worked on, because there are these nice clean layers of
Mhm.
separation. The surfaces and side effects are not embedded in the UI layer itself. It's much easier then to tell how your app's going to behave, and certainly how the UI is going to behave. It feels like a very, very natural way to encourage more separation, and cleaner
Mhm.
encapsulation. So yeah, so TCA and SwiftUI, that's basically the main
Okay.
two. And we also used, now when we started the project, Swift concurrency didn't exist, right? So
Mhm.
we didn't have actors, we didn't have a sync await. So we used Combine as kind of our primary asynchronicity model in a way.
Mhm.
So that's actually worked out pretty well. But it's interesting if you look at the way that like the proposal architecture has moved away from Combine, right? They would like, not there's anything necessarily wrong with it, but they wanted to make their architecture as sort of pure Swift as possible. When
Exactly.
Combine, of course,
It's already integrated in the language.
right,
That's
exactly. So
pretty
I
important.
totally get that,
Mhm.
and so we made some choices that I'm sure we'll revisit as we iterate on our code, right? Because you can use Combine for like all your asynchronous function calls. But it's one thing about it is that I would say Swift concurrency leverages the compiler more to help prevent you from making certain kind of mistakes, right? To really enforce, like actor isolation semantics are much
Yeah,
clear, easier to reason about. It's like, I mean, that, and honestly, that's kind of, to me, that's the main story of Swift, is that it's empowering the compiler to help you
exactly.
prevent mistakes. I mean, you can, I've worked on architectures which had a lot of abstraction, but it was all based on sort of runtime checks. You'd pass things as more opaque types, and then you'd have to dynamically typecast them into the type you expect it to be. And if that failed, then it's a runtime exception, and you can write unit tests to try to cover that. And you can, but ultimately, if you make changes and call this function from a different place and forget you need to add a test at the other side of the interface to make sure you're being passed the thing you expect, then you can introduce bugs, right? And just we're trying to rely on just test coverage to catch your programming mistakes. It's better than nothing, right? But it's certainly not. It's so much nicer when the compiler can say, no, that's just the wrong type. You can't pass that because it's not the same thing, right? I think that I feel like that's another reason why I think Swift is a great language to write mission critical apps like medical apps in, because it's such a rich type environment. It allows you to create software which is inherently safer by design,
Yeah.
which is, one of our main mantras here at Insulet is, has to be, anytime you can make something inherently safe, then that's the approach you should take. So
Yeah, yeah, definitely. Swift is becoming now with Swift 6, it's becoming a really powerful language, and not
yeah.
only for iOS, for multiple uh, operating systems like Windows, Linux. They are already start
Mhm.
using it more and more. I'm seeing something similar to Swift UI, but for Genome Project and others, which is amazing.
Right.
And like you said. Mostly the first mantra of TCA is improving the testing process, and I think testing is what we must need in a company like Tinsolet, for example. But I well, in your experience, because you have been like 4 years using TCA, and there is no silver bullet in
Mhm.
any platform or so. But there are people out there that ask me, "Hey, Pete, should I start using TCA, or how can I incorporate TCA to my project?" Or in your experience, what would you suggest for people if they want to start a new project? Would you recommend to start using TCA right away, or what are the challenges that
Yeah,
you
I
need to
would. I
work?
mean, I think that it's definitely worth a look. I would say that much, right? If you're thinking about starting a new project, I think it's worth evaluating. And one of the things about the guys over there at Point Free is they've been pretty relentless in improving their library, as much as possible, and making it easier and easier. Like
Yeah.
now they've been leveraging macros in their latest release to make it even less boilerplate one has to write, which is nice. I will say this though, because it is a third party technology. It's you want to make sure that that's way to put this, right? So you don't want to marry it so deeply that you kind
To
of lose
couple
track
it.
of
Mhm.
how the like what Apple's doing. In other words, right. So if you it's like understanding how property wrappers work and observable state and the observable protocol, and understanding how bindings work in a typical Swift UI application. Understanding really, how if you look at how Apple will write sample applications and example apps and how they view models, it's you don't want to. I would say you don't want to become so entrenched in a TCA, MVI mindset that you lose track of how MVVM works, or how how other people are utilizing the platform. It's not that there's a complete paradigm shift between the two and they're incompatible worldviews. I mean, one
Mhm.
thing that's nice about using something like TCA is you could just use it on certain features, not have to necessarily adopt it like throughout the entire app,
Okay.
if you wanted to. And like anything else, just like Swift UI, for example, it's like we certainly have. It is still a new platform and it's evolving rapidly and getting more and more powerful. But we've encountered places where there either bugs in it or limitations in how it worked, where we needed to basically dip into UI kit based implementations. And so,
Mhm.
it's important to remember that SwiftUI still is essentially an abstraction layer sitting on top of UI kit. And it'll probably be that way for quite some time. And maybe someday they'll say, "Hey, we've now SwiftUI is completely self-consistent and the UI kit's gone." I don't know when that's going to happen, right?
Yeah.
Because UI kit is too like an extremely powerful set of libraries, right? And you can do things in it that in the more imperative, or even dip into some things like the foundation libraries or core animation, whatever, that will maybe never work in Swift UI, but for many, many, many of your UX flows, Swift UI is the right level of abstraction because you don't really it simplifies a lot of things as far as how information flows into the view and how things react, and you don't need to. There's a lot of bugs that you don't have to consider,
Mhm.
um, that when you're using Swift UI because of that paradigm. But yeah, like anything else. It's important to always you have to have a broad view because a real production enterprise app is probably going to have bits of everything. Even if you're using TCA, for example, as your primary UI layer architecture, you'll probably still you may still have some imperative code or things where it's not going to work that well. It's interesting too. I see like they're also continuing to deepen their support to use TCI in a UI kit based application, right? So
Yeah.
so it's not necessarily that architecture is only designed for Swift UI. It happens to dovetail very nicely with Swift UI, right? Because it's
Mhm.
making a model, and you have something observing that model and reacting to it. But I mean, we've even used the TCA mechanisms to do headless state machines in a few different places where there is no view. It just was the right architecture to manage some complex internal state machines that otherwise would have had to write our own bespoke state machine type of code for. Um, so yeah, so it's a powerful library, and I definitely recommend people look into it because I think it's got to get it's got a lot of mind share. I think for a reason. It's really they have some
Yeah.
really great ideas. Yeah.
That is a really active community, improving
Hmm.
mostly. I mean, mostly driven by Brandon Williams and Stephen Sellis,
Yeah.
which are
Mhm.
the creators of TCA. I think definitely worth exploring TCA. But like
Yeah.
you said, so it's a third party library that you should consider if it worth the effort and learning curve to learn it, because I will say it's not obvious or trivial for most people. So the learning curve, the ramp up for new hires that in your project, that they need to understand uh, a, a couple of things before actually understanding the full mindset of TCA. Well, it takes some time. If that's what we are dealing willing to deal, that's fine. But if you need to go quickly with something, maybe you can explore it later. So it's
Yeah.
again, it
I
depends.
agree. Exactly. It depends, and like anything else. I mean, hopefully, if you're building your app in a way that's amenable to componentization or as a level of abstraction, then in theory you should be able to drop it in or at least decide to adopt it in this part of your code, without having to write everything.
Yeah.
But I will say this: I mean, I think their videos and their blog posts are worth anybody should watch them. They're very they do a really good job of breaking down the problems they're trying to solve and explaining why they made the choices they made. And you may or not agree with what they're doing, but I've every time I've watched any of their releases, I've learned something. Right, so
Yeah,
I appreciate.
definitely.
Yeah,
The videos are delicious. This is what I could. Yeah,
yeah,
yeah.
yeah,
I brought my popcorn. It's like, wow, this is like, wow,
yeah.
blowing up,
Mhm.
or using Swift in the maximum capacities. Is that, and now with
Yeah,
the what you said, with all the reducer macros and things, it's like even better, even more decouple of or reusable, for if one day you don't want to uh, continue using TCA for some reason. I mean, you have less and less layers of coupling of that. So that's amazing. So
yeah.
yeah. Um, well, John, I think we have. I'm glad that I bring you
Mm.
uh, to the podcast. I definitely, if you have the time later, you are free to come anytime you want. I think we have a lot of this to discuss, and maybe exploring other or expanding other of the topics
Yeah,
that we have
that
here.
that'd be
Uh,
great. Hopefully, I didn't do too much rambling because I mean, it's a big topic. There's a lot of things to talk about, right? But yeah,
yeah, no, no. Thanks for your time, and I know you're really busy with everything. And if you're watching this in June, so we are close to a release, so you can
right.
imagine that we are really busy.
Yeah,
Uh,
and we're
thing.
just a week out of WWDC, and I have a lot of sessions. I mean, I have to say, I'm glad. One advantage of the COVID experience with Apple is the way that now there's these much higher production values around these different sessions, and it's much
Yeah,
easier to go back and watch some of the stuff. I mean, I remember, when they were all live, and you're watching a presentation on a stage and it's recorded. Um, sometimes it wasn't quite as easy to get to the meat of the
yeah.
presentation. So I have a lot of definitely I need to go back and watch a bunch of these sessions. That's the disadvantage of being busy in the middle of release. I couldn't take the week off and watch them all live, but at least they're there. I really
Yeah,
appreciate that.
yeah.
Apple, you can
But
yeah,
mhm.
they have a whole
That's
year.
not.
Yeah,
Yeah, but that's the thing. So sometimes, I mean, there are hundreds of videos, but the thing is that some of them are latest technologies that maybe we can use right now, but we
hmm
can use it. I mean, we can watch those videos eventually. So let's just do a couple of them are about what's new in Xcode, Swift, etc. So uh, those are mandatory, but the rest, I mean, we can take our time. That's what I'm doing.
yeah, exactly. And
Yeah.
Apple has, I mean, it's such a rich ecosystem. There's so many different things going on there, right? So there's lots of fun stuff to discover. I sometimes love just watching random sessions on things that I don't think have to do with what I'm working on, just because I might learn something really interesting,
Yeah.
about. Yeah,
Yeah, it's something. Yeah, there are a lot of things to learn. That's what I love from my job and
yeah,
my career. Yeah, yeah.
yeah.
You always have to do. You will never stop learning. Yeah,
Right, exactly. And it's great.
yeah,
Yeah,
yeah.
hopefully keep me out of the old folks home for a little while longer. Yeah,
Yeah. All right, John. So, well, we are just ending this episode. Again, I really appreciate your time being here. And I really also appreciate the time from all the audience that are watching this episode. Remember that we're going to leave links or about the interesting topics that we talk in this conversation in the description below. John, I don't know. You would like to share any social media or something where people can contact you? I don't know if you
I
want
don't really. I mean, this is how old I am. It's like my social media exposure is pretty slim, but you can always ping me on LinkedIn. Maybe
that.
that's
Okay.
that's probably which is you can spell my
Yeah,
name
I
on
I,
there.
I
Yeah,
I can
yeah.
leave it
You'll
in
have,
the
you'll have a
description.
link.
Don't
Yeah,
worry, don't worry. So
exactly.
yeah, well, thanks again, everyone. And remember, if you want to learn more about any of the topics that we have talked, please uh, let us know in the comment, and let us know if you want to, have another special guest. Letter is also I'm also open to see what's on your mind, everyone. So John, again, thank you for your time.
And
Yeah,
thanks for the invitation. I enjoyed it. It was fun.
yeah,
Yeah.
awesome. And well, stay in touch, everyone. So remember, my name is Pete, and this was Swift and Tips. Thanks for watching, and have a great day.